Good morning, children. So let's continue with the second chapter, that is concentration of a solution. So concentration of a solution, depending on the amount of solute present in a solution, it can be called a dilute solution or a concentrated or saturated solution. So depending on the amount of solute present in a solution, it can be classified as dilute solution and concentrated or saturated solution. Now saturated and dilute solution. When no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. So when suppose we take a glass of water and go on mixing salt in it, so which is the solute. So after some time we'll see that glass of water can no more dissolve the amount of salt which is being poured there. That means at that temperature, when that glass of water can no more dissolve any amount of salt in it, so at that moment that solution is known as saturated solution. So which is given here, that when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. So at that moment the glass of water will be a saturated or concentrated solution. Now the amount of solute present in a saturated solutions at this temperature is called the solubility. So at this moment the amount of solute present in that saturated solution is known as the solubility. If the amount of solute contained in a solution is less than the saturation level, it is called an unsaturated solution or a dilute solutions. So that means if the amount of solute present in the solution is less than the saturation level, that means we can go on pouring salt in a glass of water and it is able to dissolve that salt. So that position is known as the unsaturated solutions, or that kind of solution is known as the unsaturated solutions or dilute solution. So that means at that a dilute solution is that where we are able to dissolve some more solute in the solution. Now concentration of a solution. It is defined as the amount of solute present in a given mass or volume of solution. It is defined as the amount of solute present in a given mass or volume of solution. So therefore concentration is equals to amount of solute divided by amount of solution or solvent. So this is the concentration. So when we are asked to find the concentration level of a solution, we have to use this formula, that is the amount of solute divided by amount of solution or solvent. Now ways of expressing concentration. So there are two ways of expressing the concentration. Mass by mass percentage of a solution. That means the mass of solute divided by the mass of solution into 100. So this is one formula, that is to represent the concentration in mass by mass. So the mass of solute divided by mass of solution into 100, where the mass of solution is equals to mass of solute plus mass of solvent. The mass of solution here, the denominator, that is the mass of solution is equals to mass of solute plus mass of solvent. And the second way is that mass by volume percentage of a solution. Mass by volume percentage of a solution. That is the mass of solute divided by volume of a solution into 100. Mass of solute divided by volume of solution into 100. Now suspension. So what is suspension? So it is a heterogeneous mixture. So it is not a homogeneous mixture, but it is a heterogeneous mixture in which the particles do not dissolve but remain suspended throughout the bulk of the medium. Example, chalk pieces in water. So if we mix some chalk pieces in water, we can see that chalk pieces in the medium, that means it is not completely mixed with the water. That means the composition is not uniform, hence it is a heterogeneous mixture, and such a type of mixture is known as suspension. So properties of suspension. So it is a heterogeneous mixture. The particles can be seen with the naked eye, as we can see if we mix chalk pieces in water, we can see the pieces of chalk there in the water with our naked eye. So therefore the particles can be seen with the naked eye. The path of light is visible through it. The path of the light is visible through it. That means it scatters the beam of light so therefore the path of the light is visible through it. If you remember earlier that the path of light in a solution is not visible, but the path of light in a suspension, it is visible, as we can see in the picture. In the solution, the path of light is not visible, and in the suspension, the path of light is visible, and also in the colloidal solution, the path of light is visible. That means in suspension and in colloidal solution, the beam of light is scattered, so therefore the path of light is visible. Point number 4, the particles can be separated from the mixture by filtration. So we can separate the particles by the process of filtration, and when the particles settle down, the suspension breaks down and the path of the light is not visible. So if we keep the suspension for some time undisturbed, after some times all the particles which are floating in the suspensions will settle down at the bottom of the vessel, and after that it will become a solution, and then the path of the light is not visible. So it is given that when the particles settle down, the suspension breaks down and then the path of the light is not visible. So the next is colloidal solution. The particles are uniformly spread throughout the solutions. In a colloidal solution, the particles are uniformly spread throughout the solution. So due to relatively small size of the particles as compared to that of the suspension, the mixture appears to be homogeneous, but it is a heterogeneous mixture. In case of colloidal solutions, the particles are uniformly spread throughout the solutions, and since the particles are very small in size, which are not visible by the naked eye, so therefore it appears to be a homogeneous mixture, but it is not a homogeneous mixture. Actually, it is a heterogeneous mixture. For example, the solution of milk and water. If we mix milk and water, we cannot see the particles of milk floating on water. It is completely mixed or uniformly mixed. So therefore, it appears as if the solution is homogeneous, but it is not. The solution is actually heterogeneous mixture. Note, the particles are very small but can easily scatter a light beam. Hence the path is clearly visible. The scattering of light, a beam of light, is called Tyndall effect. So the particles are very small. So here the particles are very small, but it easily scatters a light beam, because since it is a heterogeneous mixture, so therefore since it is a heterogeneous mixture, it will scatter the beam of light, and therefore the path of the light is visible, as in the case of suspension. As we can see in the picture, it is shown that the path of the light is clearly visible in the colloidal solution and the suspension, but it is not visible in case of solution. So this scattering of beam of light is called Tyndall effect. So it is named after a British physicist. His name is John Tyndall. So it is named after him. That is Tyndall effect. So this effect is known as Tyndall effect. Now properties of a colloid. It is a heterogeneous mixture. The particles cannot be seen with the naked eye, and the path of the light is clearly visible through it. As we have already mentioned, that the path of the light is clearly visible through a colloid. The particles cannot be separated from the mixture by filtration. So if we mix milk with water, we cannot separate the milk from water after mixing just by filtration. Again, if we leave the solution of milk and water for some time, we cannot see that the particles of milk is settling down or floating on top of water. So therefore the particles do not settle down when left undisturbed. So these are the properties of colloid. So that's all for today. Remaining we'll discuss in the next class. Thank you.